Solving equations and inequalities. These are equations involving x. There is no x squared, x cubed, or anything like that. And we'll solve inequalities with x, no x squares, x cubes, and we'll have a brief introduction to straight lines. Solve for x. Our first problem. 2x, which means 2 times x, equals 14. I think we can guess that x must be 7, because 2 times 7 is 14. If we do it as a method, we divide both sides by 2. So we're going to have 2x divided by 2, and the 2's will cancel. That's equal to 14 divided by 2, and that's 7. You can divide equals by equals and get equals. So we have x is equal to 7. In this equation, 3x is 14. We will do the same method as we did before. Divide both sides by 3. Now, the 3x divided by 3, that will leave x, but 14 over 3 is not an integer. 3 goes into 14 4 times, that's 12. 14 minus 12, that's 2. So we have 14 over 3 is 4 2/3. In this equation, we have negative 17x is equal to 2. Same method. Divide both sides by negative 17. So, negative 17x over negative 17, that's x. Equals 2 over negative 17. Do not leave negatives in the denominator of fractions. Move the negative up. So our final answer is x is equal to negative 2 over 17. This is on notation. If you see a half x, that's a half times x, that's equal to x over 2. As an example, a half of 10 is 5, and 10 over 2 is also 5. 3/5 times x is the same as 3x over 5. A mixed number, 7 1/3 times x, change the mixed number to an improper fraction. 3 times 7, 21 plus 1 is 22 over 3 times x, and we could change that to 22x over 3. In this equation, we have a half times x is 13. Multiply both sides by 2. This will give an equivalent equation. 2 times x over 2, the 2's cancel, is equal to 2 times 13, which is 26. X equals 26. In this equation, we have 3/7 times x is 5. We will multiply both sides by the flip-flop of 3/7, which would be 7/3. Now, 7 over 3 times 3x over 7. The 7's cancel and the 3's cancel. That leaves a 1. 1x is x. 5 times 7 over 3. You can think of the 5 as 5 over 1. You multiply the tops and you multiply the bottoms. So 5 times 7 is 35. And the denominator is 3. That's an improper fraction. 3 goes into 3 one time. 3 goes into 5 one time. You got 2 left over. So 35 over 3 is the mixed number, 11 2/3, which is x. In this equation, 3x plus 2 equals 9. The general method. Get the x's on one side of equal and the numbers on the other side of equal. In this particular case, we'll move the numbers to the right-hand side. Circle the 2 and move the 2 to the other side and change the sign. As we see below, 3x plus this 2 is circled. It's moved to the other side. It is now negative 2 on the right-hand side. Could have written 9 and below it negative 2. This leaves 7 on the right-hand side. So now we have our new equation. 3x is equal to 7. Divide both sides by 3. X is 7 over 3, an improper fraction. 3 goes into 7 2 times. You got 1 left, so it's 2 1/3. X equals 2 1/3. In this equation, we have 3x minus 2 equals 9. Same method. Get the x's on one side of equal and get the numbers on the other side of equal. Circle the negative 2, move the negative to the other side, and change the sign. So as we see below, 3x, the negative 2 is circled. Moved it to the other side, it is plus 2. 9 plus 2. We could have written 9 and the 2 underneath it. But we have now 3x is equal to 11. Divide both sides by 3. X is 11 over 3, an improper fraction. 3 goes in 11 3 times. That's 9. You got 2 left. So we have x is equal to 3 2/3. We have 5 times x plus 2 equals 18. Do not divide both sides by 5. What we will do is use the distributive law of multiplication over addition. The 5 is times the x, and the 5 is times the 2. So as we see below, 5 times x plus 5 times 2 is equal to 18. That leaves 5x plus 10 is 18. We circle the 10, move it to the other side. It's negative 10. You could have 18 and below it negative 10, or 18 minus 10, which is 8. And our new equation is 5x equals 8. Divide both sides by 5. 8 over 5 is 1 3/5. Now we have 7 times x minus 2 equals 3. We'll still use the distributive law of multiplication over addition. We can think of x minus 2 as x plus a negative 2. Works the same way. 7 times x, then minus 7 times 2, and equals 3. Now we have 7x minus 14 is equal to 3. Circle the negative 14, move it to the other side. It's plus 14. And our new equation is 7x equals 17. Divide both sides by 7. So x is 17 over 7, which is 2. 2 times 7 is 14. You got 3 left. So it's x is equal to 2 3/7. Our new equation. 3 times negative x plus 4 is equal to 11. Distributive law of multiplication over addition. So 3 times a negative x plus 3 times 4 is equal to 11. 3 times negative x is now written as negative 3 times x, or negative 3x. 3 times 4 is 12. And so circle the 12, move it to the other side. It's negative 12. And our resulting equation is negative 3x is negative 1. Divide both sides by negative 3. X is negative 1 over negative 3. A negative divided by a negative is a positive 1/3, and we'll just write it simply as 1/3. Now we have negative 5 times negative x plus 7 equals negative 40. A lot of negatives. We're still going to use the distributive law of multiplication over addition. Our first step, it's negative 5 times a negative x, then it's negative 5 times 7 equals negative 40. Negative 5 times negative x, you can think of this as negative 1 times 5 times negative 1 times x. A negative 1 times negative 1 is a plus 1. And then we would have 5 times x. Then we have negative 5 times 7, that's negative 35, is negative 40. Circle the negative 35, get the numbers on the right-hand side. Goes over to the right-hand side as 35. So now we have 5x is equal to negative 5. Divide both sides by 5. Negative 5 over 5 is negative 1. In this equation, we have 4 times 3 minus x plus b equal 2. We're still going to use the distributive law. It doesn't matter whether they're 2 terms or 3 terms or 4 terms. The 4 will be applied to each term. Now, we start off 4 times 3. Then it's 4 times a minus x, which we'll write as minus 4x. And then we have 4 times b. So what this leads to, we have 4 times 3 is 12, minus 4x plus 4b is equal to 2. Now we solve this for x just like we've been doing. We'll circle the 12, circle the 4b, and move those to the other side. Now we have minus 4x is equal to negative 10, that's 2 minus 12, minus 4b. Divide both sides by negative 4. This is still going to be the distributive law, but it looks like division. You can think of it as 1 over negative 4 times the negative 10 and the negative 4b. So the negative 4 goes into negative 10, and we have minus 4b over negative 4. Now, negative 10 over negative 4 is a positive number. Negative divided by negative is a positive. Okay, 10 over 4. 4 goes into 10 2 times. You got 2 left. That would be 2/4, which simplifies to a half. The next term, it's minus 4b over negative 4. The negative 4 will go into the 4 negative 1 times, and minus a negative b is a plus b. Now, let's look at this again. Minus, and you got 4b over negative 4. Negative 4 goes into 4 negative 1 times, so it's minus a minus 1b. The negative of a negative is a plus, so this becomes b. Or we could do this. We take negative 4b divided by negative 4. Apply the negative sign to the bottom 4. Okay, the negative of a negative 4 is 4, so we got 4b over 4, which is b. And we could also apply the negative to the numerator. So it's negative 4b over negative 4. The negative 4's canceled, and we still have b. This one is a longer problem. Now, on the top, we could do 3 times 4x minus 5. Use the distributive law. So we're going to have 3 times 4x plus 3 times a negative 5. Plus, then we have 2 times negative 5x minus 3. So now we have 2 times negative 5x plus a 2 times negative 3 plus the 31 equal another distributive law, 7 times x plus 7 times 4, and then we have minus 13. Let's simplify. 3 times 4, that's 12x. 3 times negative 5, negative 15. 2 times negative 5x, negative 10x. Okay, 2 times negative 3, negative 6, plus the 31. On the right-hand side, we have 7x. 7 times 4, 28, minus 13. Let's simplify. 12x and negative 10x is 2x. Negative 15 and negative 6, now that's going to be negative 21. We add it to 31, that's positive 10. And on the other side, we got 7x plus 28 minus 13 is 15. Now, we have to make a decision on which side do you want x on. I think it might be easier to always move to the x that has the higher number. So we have 7x on the right hand side. We got 2x on the left hand side. We'll move the 2x over to the right hand side. So as we see now, we got negative 2x under the 7x. Now we have to move the 15 to the other side because we want numbers on one side and x's on the other side. So we move the 15 as negative 15. So when we add the 10 and the negative 15, we have negative 5. 7x minus 2x added together is 5x. Divide both sides by 5. X is equal to negative 5 over 5, which is negative 1. That's on the left below. This is the same as x equals negative 1. So it really doesn't matter whether you solve for x if it's on the right-hand side or the left-hand side. It just might be easier to always move the x's to the side that has the bigger number of x's. In this equation, we have 2/5 x plus a fraction equal a fraction. We use the distributive law of multiplication over addition to get rid of the 5, the 3, and the 8 in the denominator. We'll go multiply by a number to get rid of the 5, 3, and 8. We multiply by a common multiple of 5, 3, and 8, which would be 5 times 3 times 8 is equal to 120. It also happens to be the least common multiple because 5 and 3 are primes, and 8 is the prime 2 times itself 3 times. Now, 120 times the left-hand side. 120 times 2/5 x plus 1/3 is equal to 120 times 3/8. So we have 120 times 2/5 x plus 120 times 1/3, the distributive law. And that's equal to 120 times 3/8. Now, 5 goes into 120 24 times. 3 goes into 120 40 times. And 8 goes into 120 15 times. So our new equation looks like 24 times 2, 48x. Plus 40 times 1, 40, is equal to 15 times 3, 45, move the 40 over, negative 40, equal 5. So x is equal to 5 over 48. We look at 2/5 x plus 1/3 equals 3/8 another way. Now we put the numbers on one side and the x's on the other side. So we'll do 2/5 times x on the left-hand side, move the 1/3 over to the other side, it's minus 1/3. Now, here's how we do 3/8 minus 1/3. 3 times 3, that's called the crisp. 9 minus 8 times 1, that's called the cross. So on the top, over there on the right, 9 minus 8. And the denominator is 8 times 3, that's the product. So it's 9 minus 8 over 24, which is 1 over 24. This product is called criss-cross over the product. It works for addition and subtraction. Now, what we have is 2/5 x equals 1 over 24. Let's multiply that. 5 over 2 on both sides. The 5's cancel and the 2's cancel. So we have x, and 1 times 5 is 5. 24 times 2 is 48. X is equal to 5 over 48. That is a fraction approach to solving the equation. In this equation, we have 0.37, decimal number, times x, plus 1.2 is equal to 17.11. Now, a method would be to multiply by a power of 10 to get rid of the decimals. Now, you multiply by 10, you move a decimal 1 place to the right. 100, you move it 2 places to the right. 1,000, you move it 3 places to the right. So in that case, we got 0.37. You need to multiply by 100. 1.2, you only have to multiply by 10. But if you go multiply the 0.37x plus 1.2 by a power of 10, we need 100. And we'll use the distributive law. If you multiply 100 on one side, you got to multiply 100 on the other side. So what we have here is 100 times 0.37x. You move that decimal 2 places to the right. That's 37.x. You don't need the decimal, so it's an integer. 37x. Plus 100 times 1.2, that's 120 dot, but you don't need the dot, it's an integer. And the same with the 1711. Now, circle the 120, move it to the other side, it's minus 120. 1711 minus 120 is 1591. Divide 37 into 1591, and it goes in evenly, you get 43. So we have the same equation again. This time, all we're going to do is move the 1.2 to the other side. So circle it. Becomes negative 1.2 on the other side. 17.11 minus 1.2 is 15.91. Divide both sides by 0.37. So x is 15.91 divided by 0.37. If you were to set this up as long division, you would want to multiply by 37, not dot 37, because you want to divide by an integer. But whatever you do in the divisor, you must do in the dividend. In our case, the dividend is 15.91. So if you move the dot in 37 2 places, you move the dot in the 1591 2 places, and we're back to 1591 over 37, which is 43. In this equation, the x is on the bottom. So it's 3 over x. 3 divided by x is equal to 5 divided by 7, or 5/7. Very simple procedure. With fractions, the criss, that's multiplication, up to the left is always equal to the cross up to the right. So 3 times 7, 21, is equal to x times 5, or 5x. Divide both sides by 5. Now 21 over 5. 5 goes into 21 4 times. That's 20. You got one left, 1/5. So x is equal to 4 and 1/5. We will now look at inequalities involving x. Now, symbols. The first symbol, less than. That means that 5 is less than 8, less than or equal. 5 is less than or equal because 5 equals 5. And negative 3 is less than or equal to because negative 3 is less than 2. Greater than. 5 is greater than 4.9999 and so forth. Greater than or equal. 5 is greater than or equal to 5 because 5 equals 5. And negative 3 is greater than or equal to negative 7 because negative 3 is greater than negative 7. Now, as we did with solving for x with equalities, moving terms from one side to the other side of an inequality does not change the sign of the inequality. When you move terms from one side to the other side, you do change the sign of the terms, but you do not change the sign of the inequality. The same applies for multiplying and dividing by positive numbers on both sides of an inequality. It does not change the sign of the inequality. So, if you wanted to multiply both sides of an inequality by 3, it's positive. You're not going to change the sign of the inequality. However, when you multiply or divide by negative numbers on both sides of an inequality, it does change the sign of the inequality. And what will follow are some examples of these facts. Now we'll solve for x with an inequality. And again, moving terms from one side to the other of an inequality will not change the sign of the inequality. Circle the -4, move it to the other side. It's +4. So the new inequality looks like 3x is less than or equal to 11 plus 4 is 15. Now we will divide by the positive number 3 on both sides, and then we have x is less than or equal to 5. Below we see a number line. We see a dot above the 5. That means the 5 is included. It's less than or equal to 5, and all the numbers less than 5. That's the arrow pointing to the left. In set notation, on the left, it's the set of x. The bar is read as such that. So we say it's the set of x such that x is less than or equal to 5. Or we can use paren bracket notation. We can go all the way to negative infinity. You can't get there, so it's not a bracket. But you come all the way up to 5. We include 5, so it's a bracket. Paren for the negative infinity. Here we have minus 3x plus 4 is less than or equal to 10. Circle the plus 4. Move it to the other side. It becomes -4. So we now have negative 3x is less than or equal to 10 minus 4, which is 6. Divide both sides by -3 and change the inequality sign. So instead of less than, it's going to be greater than. Now, -3 divided by -3 is 1x or x. And 6 over -3 is -2. So the new inequality is x is greater than or equal to -2. We see on the number line below, we see a dot at -2 because it's greater than or equal to -2. And the points are to the right. And we build it in set notation. It's a set of x such that x is greater than or equal to -2. And in bracket paren notation, bracket -2 because we include the -2. And we're going to infinity. You can't get there, so we put a parenthesis. In this problem, it's somewhat different. We have the factor x minus 3 times the factor x plus 4 is to be greater than 0. We're trying to determine all x's where this is so. Now, if two numbers are multiplied, then the product is positive if both numbers are positive or both numbers are negative. So we have two cases. X minus 3 is greater than 0, and at the same time, x plus 4 is greater than 0. Or we could have x minus 3 less than 0, and at the same time, x plus 4 is less than 0. Now, x minus 3 greater than 0, move the -3 over. X is greater than 3, and x plus 4 greater than 0, move the 4 over to the other side. X is greater than -4. So, x greater than 3 and x is greater than -4 implies that x must be greater than 3. Similarly, x is less than 3 and x is less than 4 implies x has to be less than -4. So we have an OR type solution. We have x is greater than 3 or x is less than -4. In set notation, the set of x such that x is greater than 3 or the comma or x is less than -4. In parentheses notation, it's a set of numbers from 3 to infinity union with the set of numbers from -infinity to -4. In this problem, we have x squared minus 3x minus 10 is less than 0. Now, if we could make this one look like the product of two factors, we could do the problem like we did before. Now, for two numbers, when they're multiplied to get a negative, you have to have one of the numbers to be negative and the other one to be positive. So, in the quadratic form above, -5 and 2 are the numbers such that if you multiply -5 and 2, you get -10. If you add -5 and 2, you get -3. This is a way of factoring. So we could rewrite x squared minus 3x minus 10 is equal to x minus 5 times x plus 2. Check this out. First times first, x times x is x squared. Last times last, -5 times 2 is -10. the inner product, any, is -5 times x is -5x, and the outer product, x times 2, or 2x, when you add 2x and -5x, you get -3x. So now we've expressed the quadratic form as the product of two factors, and we're trying to get this to be less than 0. So you got two cases. X minus 5 could be greater than 0, and x plus 2 could be less than 0, or case B, x minus 5 could be less than 0, and x plus 2 could be greater than 0. So we take the first case. X minus 5 greater than 0. Move the -5 to the other side. X is greater than 5. X plus 2 is less than 0. Move the 2 to the other side. X is less than -2. So we have x is greater than 5, and at the same time, that number x is going to be less than -2. There are no such numbers. So this is no solution for this case. Now, case B. Let's take x minus 5 less than 0, or x is less than 5, and x plus 2 greater than 0, or x is greater than -2. So x could be greater than -2, and at the same time x is less than 5. And that would imply -2 is less than x is less than 5. So in set notation, it's a set of x's such that -2 is less than x is less than 5, and in parentheses notation, it's all the numbers between -2 and 5 and don't include -2 and 5. Here we have a new type of equation. We're going to solve for y, and we're given that y minus 3x is equal to 10. We use the same methods with just x and numbers. So we'll circle the -3x, move it to the other side. It is now 3x. So what we have now is that y is equal to 3x plus 10. So if we want to plug in numbers for x, we could figure out y. So let's let x be 1. 3 times 1 is 3, plus 10 is 13. We could let x be 2. 3 times 2 is 6. 6 plus 10 is 16. So when x is 2, y is 16. Now, if you're given an equation of the form some number times x plus some number times y, so we got hx plus ky is equal to another number c, the desired form will always be y is equal to a number times x, and we use m, plus another number called b. Now we're given 4y minus 7x is equal to 10. Circle the -7x, move it to the other side, it becomes 7x. So now we have 4y is equal to 7x plus 10. We're going to divide both sides by 4 to get just y on the left-hand side. So as we see below, 4y divided by 4, that's y. We're going to divide 4 into 7x plus 10. 4 goes into the 7x, and 4 goes into the 10, distributive law. So we have 7/4 times x. We leave it as an improper fraction. Plus, you got 10 over 4. 4 goes into 10 2 times. You got 2 left over. That's 2/4, which is a half. 7/4 is called the slope. 2 1/2 is called the y-intercept. Now 7/4. 7 is the change in y, and 4 is the change in x. Now we have y is equal to a half x minus 3. 1/2 is the slope. -3 is the y-intercept. We put a dot on the y-axis at -3. That's the red dot. We go up 1 step, the change in y. We go over 2 steps to the right. That's the change in x. And we put another red dot. We connect the 2 red dots, and that is the straight line representing the equation y is equal to half x minus 3. You might notice on the second red dot, if you were to go up 1 step and then 2 to the right, you would again be back on that line, and you could do it again. Go up 1 step and over 2 steps, and you would be back on the line.